So here's the first example I'm going to do. Let's take a look at a satellite which is in a what is referred to as a near-Earth orbit. The International Space Station is an example. Its altitude above the ground is relatively small compared to the radius of the Earth, and so we can just assume that it's going around in an orbit which is has a radius which is equal to the Earth's radius. This makes a small error, but it'll give you the idea of what all satellites do, which are close to the surface of the Earth. If they're very far from the surface of the Earth, then what I'm saying is not true. Okay, so we'll just the first example, and it's a simple example, but also many of the shuttle was always in a near-Earth orbit, for example. Okay, so where do we start? Well, here's the International Space Station is an example of an object which is in a uniform circular motion. It's going around the Earth with a constant speed. And so we say, well, what's the acceleration of this guy? Well, the acceleration is equal to v squared over the radius of the Earth, which I'll just denote r here in my calculations. We'll put some numbers in later. Okay. All right, so this is just a Newton's second law problem. We just write F equals ma, okay, which is equal to m, the mass of the International Space Station, whatever that is, times its speed squared divided by r. But what is the force? Okay, so choose a body. I've already chosen a body. It's the International Space Station here. And I want to ask myself, what are all the forces on that body? Well, there's its own weight, mg, and there is, gulp, nothing else. That's it. And therefore, first of all, we see that the masses cancel out, and v squared then is equal to rg. Pretty simple problem, okay, which is equal to 6.4 times 10 to the 6th, and I'm going to simply take g to be 10, make this 10 to the 7th, okay, and so the velocity that you have to give to your satellite, if it's close to the Earth, is the square root of this number, which I can actually do in my head, because this is 64 times 10 to the 6th, and so it would be 8 times 10 to the 3rd. That's 8,000 meters per second. And let's put that into something which we can have a feeling for. This is about 18,000 miles per hour. Okay, that's how fast you have to get something moving in order for it to go into Earth orbit. Now I'm going to give you a website that you can go to, and you can actually play around with trying to put things into orbit. Okay, I will type the URL here. Okay, exercise for the student. The exercise for the student is, how long does it take the International Space Station to go all the way around the Earth one time? Okay,